Why is 3nm chip difficult to make? Since making chips is a matter of life and death, why do we still make it? This is the earliest chip. The circuits on it were rough, which can be made by hand welding, but to improve computing power, the number of circuits, and a lot of power, will be wasted as heat. To reduce power consumption, the circuit must be shrunk. In the following decades, circuits have been reduced from millimeter nanometers. Now it is far smaller than a grain of dust. On a single chip, can carry more than 50 billion transistors. Computing efficiency has also improved, but such lines are not only thin, but also have many layers. It's like a miniature city. Cannot be processed by any mechanical method. Engineers decided to use lights, just like building a high-rise, to carve layer by layer. Light is responsible for transferring the drawing to the chip, and chemical reagents to carve the circuit. Use opaque materials, such as chromium, are etched on a small transparent light mask. First, a thin layer of photoresist is applied to the chip. Then dry it to soften the glue. This glue is very sensitive to UV light. It will harden after exposure and lose its stickiness.
When the wafer is irradiated with ultraviolet light, where the pattern on the light mask is blocked,
remain unchanged. Where it's not blocked, the photoresist loses its and it will be washed away. In this way, the photomask is left on the wafer. Photoresist in the shape.
Etch the wafer with chemical solutions or plasma gas.
The wafer is etched to remove the part without photoresist and leave the part. The pattern on the photomask is presented. It's like carving a circuit diagram with a seal. Low precision lithography
can complete processes above 28.
At the microscopic scale, light will diffract and scatter. The higher the precision, the thinner the circuit, the shorter the wavelength of light. Below 7 nanometers. Extreme ultraviolet light that does not exist in nature. This EUV lithography machine, first, it emits metal tin droplets. Then, while the droplet is still in the air, 2 laser beams are rapidly fired. The first beam flattens the droplet.
The second beam hits the droplet with high energy.
See this? Plasma, releasing extreme UV light. Then a set of atomic silicon mirrors
reflect the extreme ultraviolet light to the mask.
To achieve exposure, such a set of beams needs to be fired 50,000 times. Exposure and timing. After exposure, we need to lay an electric grid on the building. Silicon is age. When it is injected with penta, electrons are easy to run out. When injected with triva, the electrons are easily attracted. After election, can be 4. The 2 states of the circuits switch on to 1 and 0, and these 2 numbers become the basis of all operations. Then, polish the wafer with ceramic particles less than 1 micron, and constantly rinse with grinding fluid. The difficulty is equivalent to building a railway from Shanghai to Beijing. The road surface can't fluctuate more than 1. After polishing, it can form a layer of the building.
Layer by layer, apply glue and expose.
Timely deposition and polishing, after more than 100 operations, to form the chip. The high-rise buildings in this miniature city, finally, copper and other precious metals, to make elevators for the buildings. The whole process has over 1,000 steps, lasts 3 months. Since each step requires rinsing with clean water, a wafer factory can consume 8 to 10,000 tons of water a day, and this water needs to be highly purified. To avoid tiny impurities affecting the quality of chips, a processor in your phone will consume 32 kilograms of water. In addition, the high-temperature oven must be turned on and keep the air flowing to blow away the dust. It requires a huge power supply. In addition to electricity, also requires a large amount of acids, processing gases and precious metals. So chips, especially high-end chips, are very expensive. Nvidia's high-end chips can be sold for hundreds of thousands.
TSMC, in order to produce 3nm chips,
has invested over $20 billion. So making chips is not only a matter of life and death, but also requires the entire and even the whole society.
Without a strong industrial chain, it cannot be done.